back to another math video. This is grade 4 Go Math, adding and subtracting fractions, lesson 7.5 on page 295 in your Go Math book. So we're working with this right here, our regular classwork Go Math book. And again, today we're going to be adding and subtracting fractions. So look at that page number, because there it is, and it's gone. Okay. So on this page, we are unlocking our very first problem. And it says, Julie is making a poster for the book report. Okay, so let's start off. We know it's a poster. I'm going to draw a poster. Don't know what's on the poster, don't know how much space is on the poster, but we know it's a poster. Oops. Sorry. Okay. Perfect. The directions say use 1/5 of the poster to describe the setting, 2/5 of the poster to describe the characters, and the rest of the poster will describe the plot. So we have a couple numbers here. We have 1/5 for setting, and 2/5 for, oh wait, no, 2/5 not for plot, 2/5 is for characters. Sorry, my little camera pole right here gets in the way sometimes. And then the rest is the plot. Well, I'll tell you one thing. I know we need to cut this into fifths, so let's do that. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 total sections. We need, now, one of these sections, one of these 5 pieces is going to be for the setting. So I'm going to circle this in red, and I'm going to write setting right here. Perfect. Setting complete. Next, we need 2/5 of this for characters. So I'm going to circle that in blue and write characters. And characters. And now we just have the rest for plot. Well, I mean, we can see right here that this will be plot, which means we have 2 of our 5 things, which gives us 2/5. However, let's go ahead and take a moment and really look at the math that's going on here, okay? So the example says use a model. We drew our model, we made it all happen. It says shade to represent the part for the setting. We would shade 1/5 right here. Then it says shade blank to represent the part for the characters. So for the part for the characters, we would have 2/5. And then it says write an equation for the part of the poster used for settings and characters. Okay, so right now we're figuring out how much of the poster is being used for setting and characters. So let's go ahead and do that. Let's take our 1/5. Here, let me get my colors out so we know what we're talking about. Red was our setting, so 1/5 plus 2/5, which is our characters, equals a total of 1, 2, 3/5. So for that first part right there, we get 3/5. Now it says, what does the part of the model that is not shaded represent? The not shaded part represents our plot. So let's write not shaded is plot. Or if you're like me and you already wrote plot in these 2 parts, then the part that's shaded in the brown or that has the brown writing in it is our plot. Write an equation for the part of the poster that will be used for plot. Okay, well, let's take a look. Our whole poster, let's get a little bit more board space here. Our entire poster is 5/5. Again, if we take another look up here, we have 1, 2, 3, 4, 5. The whole thing is 5 of 5 pieces, so we have 5/5. Now, we're going to subtract 3/5 because we need to know how much our plot is going to be. So if we subtract 3/5, we get 5 minus 3 is 2. We don't subtract the bottom. We get 2/5. So Julie will use 2/5 of the poster to describe the plot. So just like that, I mean, yes, we drew the picture and we already kind of knew from the beginning, but we showed it with the math. We showed our work. We proved our point. But after all that work, after everything we just did, our friend Luke comes in and tells us something. He thinks that we're wrong. Okay, so I'm going to go ahead and erase this. You can always go back in the video if you need to see it again. However, Luke says we're wrong. He says that it should actually be 1/5 plus 2/5 equals 3/10. This is the answer Luke gave us, and he says this is how much of the poster is used before we use the plot. And I say, you know what, Luke? Unfortunately, I'm going to have to disagree with your disagreement because we never add the denominators. This is a no-no. So let's cross this out and put 3/5 right where it belongs. At the bottom of this page, it says, Luke says 1/5 plus 2/5 equals 3/10. Describe his error. If I were to describe his error, I would say something like, Luke added the denominators, which is something, sorry, I'm writing really fast, something we never do. Oh, you can't even see it. My goodness, I'm over here writing away and you can't even see what I'm writing. Luke added the denominators, which is something we never do. So if we didn't add the denominators, we would end up with 3/5, which is the correct answer. 1/5 plus 2/5 equals 3/5, not 3/10. Make that disappear forever. Okay. Again, today's lesson is not going to be too long, so we're going to go ahead and move right into the next part. So flip your page, just like I'm about to. And we are now on page 296. So at the top it says common denominators. Fractions with common denominators represent wholes divided into the same number of equal-sized parts. To add or subtract fractions with the same denominator, you can add or subtract the same number of parts given in the numerators. Basically, it says is if it has common denominators, you can add and subtract it. That's the short version. So in the example, though, it says complete each equation, and it gives you word problems, too, to go along with our regular math problems. So we're going to go ahead and kind of just show you what we're going to need to do to solve these problems. So this one says 1/4 sized part. I'm going to write it a little bit differently than the way it shows. Plus, that's going to be my plus sign. And then we have 2/4 sized parts. And then it equals blank 4th sized parts. So for this word problem, we're just looking at the words, and we have 4th size part, 4th size parts, 4th size parts. So that back half is all the same, which means we can just jump right in and do our 1 plus our 2, which equals 3, and we have 3 4th size parts. Now, this is the word version of adding with fractions. So let's take a look at what it would look like if we just did it with the numbers. We'd have 1 4th size part plus 2 4th size parts equals 3 4th size parts. So 1/4 plus 2/4 equals 3/4. And actually, this whole thing would be your answer. Just like that. Let's go ahead and do one with subtraction and see kind of what it looks like now as well. So let's go ahead and erase this. And if you're looking and you're following along on the page, you're going to notice I'm skipping a problem. That's okay. I believe in you. You can do it on your own. However, this one says 7/10 size parts. So we have 7/10 size parts minus 4/10 sized parts equals blank 10th sized parts. And again, the reason why I wrote it this way, especially with the minus in the middle, is just because I'm limited on space. So this is what I'm working with. So we have 7/10 size parts minus 4/10 size parts equals blank 10th size parts. Once again, our back half all matches. The 10th size parts are all the same. There's no, doesn't say like 6th size parts minus 4th size parts. They all say 10th size parts, which means we can do 7 minus 4 equals 3. Now, once again, let's go ahead and take a look at the math and see how this actually works. We have 7/10 size parts minus 4/10 size parts equals 7 minus 4 is 3. We don't subtract our denominators, so that stays as 10, and this is your equation and answer. So just like that, we subtracted some fractions. Okay, so let's go ahead and do a couple more of these as practice. So I'm going to go ahead and erase this. One more peek if you need it. There it is. Pause the video if you need to, and whoop, it's gone. Okay. So now we're just going to add and subtract fractions. And again, you can use any tool that you need to make this happen. Okay? If you have other ways that you can do things, go for it. I'm just going to be doing the basic adding and subtracting of fractions and kind of just mentioning a few things. So the first example I'm going to give us is 3/12 plus 8/12 equals. Once again, our denominators are common. We have the exact same denominator. So we do 3 plus 8 equals 11. Once again, we never, ever, ever add our denominators together. So we have 11/12, which would be our answers. Look at that. Okay, moving on. The next one is going to be 6/10 minus 2/10 equals what? If you said do 6 minus 2 equals 4, and again, never, ever, ever subtract your denominators, which gives you 10, 4/10. If you got 4/10 as your answer, congratulations. You just subtracted fractions properly. Next one. Let's go ahead and do 3 more of these. 3 more. Let's do, oh, this one's going to be cake. 1/4 plus 1/4. This might even help you make a cake someday. Equals 1 plus 1 is, oh, wait. Hold on. 1 plus 1 is 2. 4 plus 4 is 8. Wait a second. Hold up. What did I do wrong? If you said that I added the denominators and I'm never, ever, ever supposed to do that, you are correct. Never, ever do that. So let's just get rid of that whole thing. Your answer is going to be 2/4, not 2/8, 2/4. Okay. Moving on. Let's see. That was 3. We're going to do 2 more. 2 more math problems. Let's do 9. Let's give you some fractions that you might see that are a bit confusing, but it's all the same concept. We're going to do 9/7 plus, no, not plus, minus, sorry, minus 3/7. Now looking at this, you're like, Mr. Edwards, how do I have 9 out of 7? It just doesn't make any sense. Well, really, we have 9/7 size parts. So remember how we were doing those word problems? And we were saying 1/4 size part? Well, we have 9 7th-size parts, and we're subtracting 3 7th-size parts, which equals, guess what? Nothing changes from the way that we add and subtract fractions. 9 minus 3 is 6, and then again, you never, ever, ever subtract your denominators, so you get 6 sevenths, and that would be your answer. And let's go ahead and do one more for good measure. In fact, let's make this one just a teeny bit more challenging. And by teeny bit, I mean it's not anything crazy. We're going to do 2 6 plus 2 6 minus 1, no, minus 3 6. Bum, bum, bum. Oh my gosh. There's an addition and a subtraction problem in the same problem. Guess what? For this, when it's adding and subtracting, you can just go left to right. Nothing big, nothing crazy. So, the way I would solve this is I would just go like this. 2 6 plus 2 6 equals 4 6. Now you can subtract your 3 6. 4 6 minus 3 6 equals 1 6. So the answer to your equation is 1 6. Nothing crazy. We did it. Woo! Okay. So with that being said, that's it for today's lesson. I know we've been adding and subtracting fractions for a while. We're going to be moving on into some deeper stuff coming after our mid-chapter checkpoint. But that's it for today. So yeah, see you later.